All right. This is the post lab for the Lab 1 energy survey. The reason why we do post labs is to help you answer the questions after you've done the lab, and secondly, to help you learn a little bit more. All right, this is a lot in this particular lab, so I'm going to have to go kind of quickly. We'll see how far I get. I only got, 9 minutes and 30 seconds left. All right, so first off, I want you to make sure that you put in your answer in kilograms, not grams. So you take the number of grams and divide it by 1,000. That'll make the conversion. And here it needs to be in meters, not centimeters. So you take the number of centimeters and divide by 100, and that will give you your meters. Next, you need to, in the forms of energy section above, highlight all of the forms of energy you observed, which you should have done during the lab, and then explain why you selected each. So, gravitational. Why did you select gravitational energy? Well, you selected it because we lift the ball above the ground, and that is creating gravitational energy. In all of this, right, energy is not being created or destroyed, it's just being transferred. So you're transferring that energy that you have in your muscles, it's being transferred into this gravitational potential energy in the ball. All right. Then you would go on and list elastic. So why do you have elastic? Well, because when the ball hits the ground, it deforms, and that energy gets stored in that deformation of the ball, and then it goes back to its original shape and it shoots back out. So there for a moment, it's stored as elastic potential energy. Now, this is a good time to quickly point out that for this portion and all the other portions that deal with this part, this is a really good page 13 of your book. So make sure you reference that as you go through, because it explains each one in detail and I think is quite helpful. All right, back to the lab. So then you would need to go through and also mention that mechanical. Why mechanical? Well, because mechanical is the energy of motion. It's motion energy and the ball is moving. Why thermal? Well, because when the ball hits the ground, it actually creates friction. That friction creates heat. And so some energy is lost as heat energy. Lost is not the right word exactly, but is transferred into heat energy. And then sound energy. You can hear the ball bounce. So make sure that you discuss all of those things when you write this up. Describe the benefits and risks of the different energy forms you highlighted. The good news is you only have to do that once for each form of energy. So if you describe gravitational on this page, you do not have to then re-describe gravitational at any other time on these pages, okay? So what's a benefit of gravitational energy? Well, you can use it to, the gravitational energy in water, when it runs through dams, can be used to power cities. And the downside is if you're underneath a tree branch, when it breaks, you could get hurt. So that's the idea there. Now, you'd also need to mention elastic, mechanical, thermal, and sound, but then you'd no longer have to do those in the future. Based on the data you collected, describe the changes you noticed between the first and second bounce heights of each ball. This one I want you to do to show me with data. And what I mean by that is, so you'd say ball A, right? It equals, let's say it was 0.54 meters on the first bounce and 0.34 meters on the second. All right, it's always good to explain your answers using the data you collected in a lab. All right, so you'll also need to do B and C, etc., and get those all filled out with the correct amounts. This one's straightforward. Use the term potential energy to explain why you think the second bounce can never be higher than the first. And actually, I put this in the wrong spot. This really should be down here on number 5. So I think you can handle that remember, potential energy is stored energy. That's what it is a synonym for. Recommend some factors that might affect the height of the first bounce. Think of things like the material the ball is made out of, the surface that it lands on, etc. I think 3 things would be great on that one. And then this one, I'm just going to tell you this and let you think this one through. But potential energy, which is abbreviated PE, equals mass times gravity times height. When you multiply those things together, you get the total potential energy. So the height we lifted all the balls was the same, 1 meter. The force of gravity on all the balls is the same. It's 9.8 meters per second squared. We'll learn a little bit more about that later. So the only variable is the mass. So think mathematically what happens when you would multiply these 3 numbers together, which would give you the biggest potential energy. And then compose 3 questions based on your observations that could be answered through further inquiry. So be creative, come up with some neat things you could do here. All right, the reaction one. When you describe the changes in the bottle, make sure you talk about things not only that you see, but also things you heard or you smelled or you felt. Remember, we talked about temperature change. Changes in the balloon. All right, talk about what you saw there. Once again, you're going to highlight the forms of energy and explain why you selected each. Remember, if you've already described one of these in an earlier one, you no longer have to do that. You don't have to describe the benefits and risks over and over again. But if there were any new ones, definitely put it in. How could you prove that baking soda and vinegar contain potential energy? Remember, the definition of energy is the ability to cause change or the ability to do work, but I like this cause change. So how can you prove that vinegar and baking soda cause change when mixed together? What might you do to determine the identity of the gas filled in the balloon? Well, I did a demonstration with a candle, and we talked about that in class, so use that example. And then once again, further inquiry questions. The balloon, all right? This one's highlighted with electrostatic. There's more as well. The fabric that you used was wool, if I didn't mention that. And then, once again, we're going through and doing things that we've done before on the prior ones. I think these questions here you can tackle on your own. You should be able to handle them. The magnets. The one thing I want you to mention is talk about both the attraction and the repulsion of the magnets. Moving on, how did your predictions about each material compare with your observations? So go back up here and explain how your prediction and your observation matched up or didn't match up. A lot of times people think if it's metal, it's magnetic, but that's not the case, right? The penny and the quarter are both metal, but they were not magnetic. So you might want to talk about that. And that might be a difference that came up in this one. So here, think about terms of energy. Does a piece of tape, when it picks something up, is there energy involved? Think that through. What experiences or observations about magnets could you use to show someone that magnets contain potential energy? Once again, the ability to cause change. How can magnets cause change? Voice. We get to the questions on that. Which sound, soft or loud, requires more energy for you to produce? Explain how this relates to your answer in question 1. I think when you talked about on the X and Y axis, I'm running out of time, so this will be the last one I do. But on the X and Y axis, right, on the Y axis, we had decibels, which is a measure of, or a unit for volume. And on the X axis, we had time. So the higher up on the graph, right, the higher the amount of decibels. So that is equating to energy. I think I've run out of time. Finish up the rest. You should do just fine.